Welcome student in our today's online section of subject Mechatronics. Today we are going to discuss the applications of Mechatronics system. We will take the numericals of the transfer function in the next section. Today we are going to complete this theoretical concept of applications of Mechatronics system. Okay, so focus on your screen here. So in this screen you can see we are going to study this anti-lock brake system or anti-skid braking system. So this anti-lock braking system, short form ABS, it is the best application of Mechatronics system. So what is this anti-lock braking system? Anti-lock braking system means here we are going to make a lock to the speed reduction or make a lock to the brake of a particular wheel, and this anti means we are going to avoid this locking of the particular wheel or avoid the locking of braking system here. So this anti-lock brake system ABS helps to prevent the brakes from locking. Sometimes what happens when the driver put his leg on the brake system, sometimes because of this anxiety he apply a lot of force on this braking system on the brake, which causes the brake to lock, and because of this the running wheel stops instantly, and there will be the loss of balance of the vehicle and accidents may occur. Suppose you are driving a two-wheeler on a road. Here you can see, suppose this is the road and you are the driver, you are driving this two-wheeler, and suddenly you saw a obstacle is came between the road. So what will happen? Because of the anxiety you start to apply the brakes, and you apply the brakes on so much pressure, and because of this the wheel get locks, and as the one wheel get locks, there is the loss of balance of the bike, and you may fall and accident may occur. But if suppose your vehicle is having anti-lock braking system, so anti-lock brake system what does, though you apply a lot of pressure on the brake, this anti-lock braking system slightly remove the pressure, it only reduces the speed of wheel but not completely lock it. Anti-lock means it does not lock the wheel, it reduces the speed of this wheel but does not lock the wheel, so that only the speed is get reduced and balance of this vehicle will not be disturbed, and you may cross by the obstacle, and you will not collide on the obstacle, or you will not skid here. So that's why we call this system as a anti-skid system here. So here this ABS monitors the speed of each wheel to detect the locking. When it detects sudden braking, it will release braking pressure for a moment and then provides optimum braking pressure to each wheel. Normally you may notice that when you are on the full speed on the two-wheeler, you applied the sudden brake on the back rear wheel, then what will happen? The rear wheel stop instantly, but the front wheel having its speed because of this moment of inertia, and what will happen? You get skid. So to avoid this, there is a anti-lock braking system which keep watch on the speed of both the wheels, and though you apply a lot of pressure on the brake, it reduces it and keeps a optimum speed of the two vehicles. So it provides the optimum braking pressure to each wheel, and it keeps the balance of the vehicle. Here for this two-wheeler also, suppose we are having you are taking a turn, and for taking the turn, suppose you are with the full speed. So with the full speed, for taking the turn, which is very sharp one, you start applying the pressure on the wheel. As you applied the pressure on the wheel so intensely, so there will be the locking of the wheel may occurs, though the particular will get locked, but other wheels are having on the full speed. So there will be the skidding of vehicle may occur. So to eliminate this, we are having this anti-lock braking system which provides the optimum braking pressure on all the wheels or on each wheels, so that the vehicle's balance will not be disturbed. So this is the anti-lock braking system. Again listen me. Anti-lock braking system, it is a system used in vehicle to avoid the skids. ABS comes into action when the sudden brakes apply on a system. When sudden brake applied on a wheel, then possibly of wheel lock. Due to this wheel lock, driver loses control on the vehicle. The ABS prevents the wheel from locking, thus preventing uncontrolled skidding of the vehicle and reducing the distance travel with falling. This anti-lock braking system is a safety system used in cars and other automobiles that prevents their wheels from locking and helps the driver maintain the steering control. Also known as anti-skid braking system, it sometimes enables the wheel of vehicle to maintain a attractive contact on the ground so it does not go into the uncontrollable skid. Anti-lock braking system generally offers improved vehicle control and helps to reduce the gap between the dry and slippery surfaces. Then here we are having this diagram of this anti-lock braking system. Suppose here this driver pushes the brake pedal. Suppose the driver pushes the brake of the wheel so intensely. So what will happen? Piston of the piston pushes the brake fluid, and then this brake fluid and then this brake fluid moves to this wheel, causes it to stop. But as you pushes this brake with very high pressure, so lot of fluid start applying the high pressure on the wheels, which may cause the wheel to lock. But to avoid this locking, we are having here this anti-braking system. We are having this anti-lock braking system. So how this works? This anti-lock braking system having a sensor which detects the speed of this vehicle, and this sensor sends this speed to this control unit, and this control unit here it removes this pressure from this pressure line, and this high pressure fluid is either sent to the accumulator or saves in the accumulator, and the optimum or safety pressure is applied on the wheel, and it avoids the locking of the wheel here. So what is, as the speed is sensed, then what happen? Control unit activates accumulator and pump. Here fluid is blend off into the accumulator. So this high pressure fluid in this line is moves to the accumulator or reservoir. This releases the brake pedal pressure. Fluid is pumped back into the reapply pressure. Here for this 7 it is again reapplied. Then process 6 and 7 happens up to 15 times per second, means a very low pressure, or it is a very quick process, so that quick process may 6 to 7 times happen. It is happen 15 times per second, means the locking is eliminated here by applying a suitable pressure by using this anti-lock braking system. Then operating principle: limiting the pressure to any wheel which we deaccelerated too rapidly is the basic principle employed in anti-lock braking system. Suppose that we are driving the two-wheeler and normally we applied the pressure on the rear wheel, and because of the applying brakes to the rear wheel, it will stop or deaccelerate too quickly or too rapidly. So the main function of this ABS is to limiting the brake pressure to this rear wheel, which is going to decelerate too rapidly. This is the basic principle of this anti-lock braking system. A speed sensor is used for measuring the speed of the wheel and send it constantly to the computer. Computer here means anti-lock braking system. Depending on the initial brake pressure and the speed of the wheel, the computer modulates the brake pressure as fast as 15 times per second. So this is the complete working of this anti-lock braking system. Then we are going to discuss about these components of this anti-lock braking system. So its main components, major components is speed sensors, then valves, then electronic control unit and hydraulic control unit. Here we are going to discuss it. The speed sensors keeps an eye on the speed of each wheel and decides the necessary acceleration and deceleration of the wheels. It composed of an exciter and a wire coil magnet assembly which creates the pulses of electricity as the teeth of exciter path in front of it. Then the next component is valves here. ABS regulates the air pressure on the valve's brake during the operation. The brake line of each brake has a valve that is controlled by ABS. The open valve allows the pressure on the master cylinder to transfer to the brakes. When the brake valve is closed, the pressure from the master cylinder to the brake is reduced. Then it has electron control unit. The ECU is an electronic control unit that captures and filters sensor signals to measure wheels rotation speed and the acceleration. According to data analyzed by the ECU unit, it receives signals from the sensor in the circuit to control the brake pressure. Then again it has the hydraulic control unit. The hydraulic control unit receives signal from ECU in anti-lock conditioner to apply or release the brakes. The hydraulic control unit controls the braking by increasing the hydraulic pressure as well as by passing the pedal to reduce the braking system. The main function is to avoid the skidding of the vehicle here. Again, this engine management system is again an example of the Mechatronics system. So this engine manufacturing system having the input signals which are sensed by the sensor such as throttle position, then accelerator, mass airflow, battery, temperature, NOx sensor, oxygen sensor, fuel pressure. So all these are the inputs, and here we are having this output which is in the form of power relays, then fuel pump, oxygen heater, cam control, recirculating valves, idle control, others. So all these are the outputs are controlled by the Mechatronics system here. So this engine management system, it is again an example of the Mechatronics system. Here you can see this injection drives which injects the fuel inside the engine. Then this ignition pre-driver means the ignition of this IC engine also controlled by Mechatronics here. Then motor drive, the turbo, throttle, EGR, all these are the outputs which are controlled by which we need to control while driving an engine. So all these are the parts of this engine management which is controlled by the Mechatronics system here. Then here is a home temperature control. So home temperature control, here you can see home heating control loop block diagram which is having a setup point here, and then setup point, then we are having a thermostat controller, then furnace fuel valve, then home heating process, and here we are having the feedback loop. So the process variable here is house temperature. So to control this house temperature, here we are going to use the Mechatronics system which is having a setup point, then thermostat controller, then furnace fuel valve and home heating process. All these are the processes. Then measuring sensors are thermistors or bimetallic strip coil or analog motor. model. The measurement process variable signals are the signal transmitted from the transistors. The setup point is the desired house temperature. Here the setup point is desired house temperature, which takes an account of the feedback which is coming from the room. Controller output is a signal to fuel wall actuator and furnace burner. It is a furnace burner. We will supply this controller supplies the signals to the furnace burner, and the heated air is sent to the house, and the output of this heated air house temperature is again sensed by the thermistor and sent is to the setup point where the error is calculated there. This manipulated variable is the fuel flow rate to furnace. Then disturbances are heat loss from doors, walls and windows, changing outdoor temperature, sunrise and sunset. So this home temperature control system, it is again an example of Mechatronics here. Then automated car parking system. An automated car parking system is a Mechatronics system designed to transport and park cars automatically. Then again, door system or door system module of any automobile, it is a part of Mechatronics. Then pick and place manipulators. So this pick and place manipulators are mostly used in the automated industries, where it pick a particular product and place it on a particular place. Okay, so this pick and place manipulators have actuators, torch, it has vision, the manipulations, all these are its components. Again, this piece counting system, here this piece counting system, it is also a application of Mechatronics. Here manufacturing produces a large number of objects like nuts, washers, bolts, box. This counting of this object take a lots of your time once a large order is received. So the automatic counting system will use for such kind of bulk orders. This reduces the chances of error in count. Infrared sensors can be used for object sensing and depends on the reflectance characteristics of object. Selection of best material handling equipments and using of IR sensors will be used for object count, thereby increasing the productivity and reducing the operational cost. Again, we are having this CNC machines. So the CNC machines are the computerized numerically controlled machines, which are the applications of Mechatronics. This computerized numerically controlled machines is the best and basic example of application of Mechatronics in manufacturing automation. Efficient operations of standard machine tools like lathe, milling machine, drilling machine relies on operation ability and training. Also, lots of time is consumed in work part setting, tool setting and controlling the process parameters, means feed, speed, depth of cut. So typical machining is slow and costly to fulfill the challenges is often changing product or part shape and size. Computerized numerically controlled machines are currently widely utilized in a little to massive scale industry. CNC machine tools are integral, a part of computer aided manufacturing or computer integrated manufacturing system. CNC means that operative a machine tools for by a series of coded directors consisting of numbers. You already know that G codes and M codes are probably used in the CNC machine. The components of CNC machines are machine tools, then actuators and drive circuits to operate the actuators, sensors, then conditioning circuits of the sensor signals, then controllers and mechanical body and parts. All these are the parts of CNC machine. Also, this household application of Mechatronics is washing machine. In a domestic washing machine, a number of operations need to be carried out in a correct sequence. This count involves the pre-wash cycle. Once the clothes within the drum are given a wash in a cold water, followed by a main wash cycle when they are washed in a hot water. that a rinse cycle. Once the clothes are rinsed with the cold water variety of times, followed by spinning to remove water from the clothes. So here also it is best example of application of Mechatronics in the household system. Okay, so today we are stopping here. In the next section we will see about the numericals of transfer functions. Thank you.